7th grade lesson 3.3 is subtracting rational numbers. The majority of this lesson is really showing you how to utilize a number line to show the answer for the subtraction of rational numbers, including integers. But I'm going to kind of try and use both because I want to just make sure that the skills are refreshed on how to subtract your integers, even if there are in rational number form, if there are decimals or fractions involved. So I want you to be able to do both, but also recognize what's happening on a number line. So let's look at our first example they give us. So our first example is 5.5 minus 7.25. That's like saying $5 and 5 dimes, $5.50, minus $7.25. And your brain's probably going, wait, if you only have $5 and 5 dimes, $5.50, I don't have enough to give that away. So you're still going to owe some money, right? So just like we did when these were whole numbers and not decimals, and again, this can be rewritten as 5.5 plus that negative 7.25. That's the same thing. Your brain starts to recognize that that's really what's going on. I'm putting together a positive with a negative. And there's more negative than there is positive, so I'm still going to owe money. So my answer is going to end up being a negative in this case because there's more negatives than positives. And I simply need to find out what the difference between these two are so that I can find out how much is still owed after some of that was paid back. So what's the difference between them? So I take the larger absolute value and subtract from it the smaller absolute value. Remember that we must line up our decimals. I'll give a 0 there just so it lines up nicely. Let's find the difference between them. I do need to borrow. 12 minus 5 is 7. Decimal comes straight down. So it's going to be $1.75 that is still owed. So that's kind of the refresher on handling those calculations with rational numbers, whether it's decimals or fractions. Here's the decimal version. Let's also look at it on the number line though. So you'll see on my number line, I went ahead and marked out from 0 to 7, and then I went down negative 1, 2, 3. I also broke these into fourths, 1, 2, 3, 4. So the 3 lines will give me 4 segments. And the reason I chose fourths is because the smallest broken piece is a quarter size piece. This is half piece and this is quarter piece. So I thought, well, I'm going to break it into the smallest level of pieces. So it's broken into quarters, 1, 2, 3, 4, 1/4, right? So you just go ahead and start at the positive, or at the amount that's to start with. This is a positive 5.5. So on the number line, I will mark positive 5.5. Let me see what color I want to do that. So 5, 1, 2, 3, 4, 5, and then halfway, 0.5 is halfway, right? So I'm going to mark right there. That is 5.5. And from there, they want me to take 7 whole and a quarter more, 25.25, 25 hundredths away. So I'm going to start with the 7 wholes. So I'm going from half to half because that would be a full amount, whole. So here I go, counting down. I go 1, 2, 3, 4, 5, 6, 7, and then they want, that's my 7 whole, and now I need that quarter piece, the 1/4, so just one little spot here, and that lands me right here. So what is that as a number? Where it's 1 whole, negative 1 whole, sorry, negative 1, and 1, 2, 3 out of the 4 broken pieces, negative 1 and 3 out of the 4 whole pieces, also known 3/4 and $1 is 75 cents, right? So you can write it as negative 1.75, same answer. So there you go, both ways. On the next example, it's with fractions, and I know a lot of you are still wrestling with the decimal calculations and fraction calculations, and this year around it will feel a little easier, and next year will feel even easier, and pretty soon you won't feel as nervous about dealing with fractions anymore. So it just takes a couple years for our brains to get used to it. So we'll be patient with our brains. So let me remind you again, this lesson is wanting us to do it on the number line, but I want you to see it both ways because it's a good way to dust off those cobwebs for the fraction and decimal operations and our integer calculations review. This is a negative 1/3, and this double negative here really can translate as the opposite of a negative 5/6 with no number in between. Opposite of a negative 5/6 is a positive 5/6, so I'm going to rewrite that as negative 1/3 plus 5/6 because that's the opposite of a negative. And then to remember my fraction skills, in order to add fractions together, I need to have a common denominator, and I do not here. So that's okay though, because I can make 3 become a 6 by multiplying by 2. I just need to make sure that I multiply best friend by 2 as well to keep it equivalent. One slice of pizza out of a pizza cut into 3 pieces would end up being 2 slices of pizza out of a pizza cut into 6 pieces. It's an equivalent amount, and that's our goal. So we're going to do 2, 6. That's a negative. Don't forget that negative, Mrs. Sanchez. Plus 5, 6. Now my denominators are the same. It stays the same. And now I'm just doing like I did at the beginning of a few lessons ago. I'm just looking at my numerators. This is a negative 2 and a positive 5. I owe $2. I have 5 in my pocket. I'm still going to have some money left, right? How much money am I going to have left? $3 left, so that's a positive 3. I'm going to leave that. I know I can reduce it down to 1/2. I'm going to leave it as 3, 6 for right now, so that we can see that on the number line. Well, we'll do both. We'll show it reduced to at 1/2. All right, now let's look at it in terms of being on a number line. All right, so here is my number line. I did here between 0 and 1 whole, and then between 1 and 2. These are 0 and a little more, and 0 and a little more, and my answer ended up 0 and a little more. So it's all living in this realm here, actually. This one goes backwards. I guess I need to add that. Give me a moment. Okay, that's better. And you'll see my hash marks. So here's 0, and there's positive 1, and there's negative 1. Broken into 1, 2, 3, 4, 5 sixths here, and 1, 2, 3, 4, 5 sixths here. I chose to do that on purpose. You probably can guess why. Why did I choose sixths as my breaking up point? Because that's the smallest pieces that this was broken into. So I'm going to go ahead and start at this negative 2 out of 6. So I'm going negative from 0. I'm going negative 2 of those 6 broken pieces, and I'm going to mark it there. That is my starting point. To that, I'm going to add 5, 6, going positive, the positive direction that way, 5, 6. So there's 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and I land right here at 1, 2, 3 out of 1, 2, 3, 4, 5, 6 equal pieces in the positive, which of course is also 1/2 once it's reduced. So there it is calculated, just to refresh your memory, and there it is on number line form so your brain can see it. The next example is Joe who is swimming in the water, scuba diving or something, and he dives 2.5 feet below sea level. So in our brains, hopefully by now our brains are kind of like, yes, that's below sea level is a negative. So we've got a negative 2 and 1/2. And we're putting that together with, he then goes another 7.5 feet more below. So he's even going further, deeper. So he goes deep and then deeper. So we're adding those together to become even more deeper. So here is our equation. You could also, and in the book they actually do write it this way, they say you have a negative 2.5 and you subtract 7.5 from that also. These are the same. You're putting a negative 2.5 together with a negative 7.5. Negative 2.5 being put together with negative 7.5. So your brain starts to recognize that those are kind of the same thing. It just takes some time. I show that I'm putting together the 2 negatives here. Here I just have the 2 negatives there, and it's takeaway. So it's a similar thing. Anyway, so in order to add these together, I know I'm going this deep and then this deep more. I can take my whole number amounts, 2 and 7, that's going to give me a -9. But also, I have this 1/2 and this 1/2 that I'm putting together. I went 1/2 deep and another 1/2 deep. That's a whole nother -1 deep when you put those together. So it will all equal a -10. He went -10 deep. Let's see that on a number line. Okay, and in the book they did their number line horizontally, and to me, because he's swimming under the water and this is 0 is representing the sea level, I just went on my brain wanted a vertical number line. Either way, whichever works for your brain. And I'm going to start where he initially dove down to. Oh, and by the way, just to orient yourself with the number line, I didn't mark each white hash mark because I didn't have, my pen was too big, but each white hash mark is one full, so -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. Then it's always good to orient yourself with whatever the number line's looking like. Then the red hash marks are the marks that I put in half. The reason I'm marking half marks is because I know I'm going to need them for this problem. So every whole one was marked in half with the red. So that will help me as I go through this. So I'm going to start at -2.5. There's -1, -2.5 right there. I'm going to go ahead and mark that. That's my starting point. From there, I continued down another -7.5. So we're going to go from there. 1 full from half mark to half mark, 2 full because I've started at a half mark, 3, 4, 5, 6, 7, and now do that 1/2 bit right there for the -7.5, and there is my answer right there at the -10. So there it is on the number line as well. Alright, and finally the example they give us on page 78 says that how to find the distance between two numbers. When we're looking for the difference in distances, we will use subtract. But when you're dealing with these negative numbers, it's interesting how they work out. Just trust your steps and they will take care of it for you. So this cave climber, so it's a cave and it must go below sea level, although it's not filled with water. They climbed from -11 meters up to -5 meters. So I really am looking for, and I'll draw the picture too, so they're in a cave and they're at a -11 meters, but they climbed up to -5 meters, and we want to know how far up we climbed. We want to know the difference between those numbers. So when we're looking for how far we've covered, we look for the difference between them. So we have a -11 and a -5, and we want the difference. You know by now that that is subtract. Well, look what that does. Double negative forces my positive. I have a -11 plus 5. And that gave me, I have $11. I owe $11. I'm sorry, I owe $11. I have 5 in my pocket. I still am going to be -6. So I really went 6 meters from here to there to get to that point. And since distance traveled, the reason this is 6 meters and this is a -6, distance traveled is neither a negative nor positive. So we ended up with a -6, but distance traveled is either up or down is that many meters. That's how much they traversed, so that's why we went to 6 meters. That's how much they traversed or traveled. Let's look at that on a number line. So we're starting point is -11 down here. I'm going to mark that here, -11, and I went up to -5, so we wanted to get to -5. So how much do we cross over to get to that point? We cross over 1, 2, 3, 4, 5, 6 meters to get to that point. that's how many meters it took that we traveled to get there. So that's how distance is handled. If they want to know the difference between the two, you would subtract and then you would get your answer there. Or you could show it on a number line. So hopefully that kind of explains how that looks and you get comfortable using those number lines and comfortable working with those numbers. And of course, I'm happy to help you if needed.